All right, so number 3, it says, which of the following describes the sequence? 8, 6, 4, 2, and then ... Now, this is the section 8-2 stuff. This is one of the videos that you should have watched while I was away. Remember, when you have a sequence, what's the first thing you need to do?
Find the difference.
Okay, find the difference, but really even before that, I would have you guys
Make a chart.
make a chart. What are these values? X or Y?
Y.
Those are our Y values, okay? They depend on what? The X, but what would X be then?
1, 2, 3, 4.
Okay, because they depend on what number in the sequence they are. What number you have here depends on, if it's the third number in the sequence, then it's going to be 4. If it's the second number in the sequence, it's going to be 6, right? So we control what number in the sequence we're looking at. The numbers are 8, 6, 4, 2. Now obviously, what's the fifth number in the sequence?
0.
0, right? You guys can see that. But if you're looking for the 14th number in the sequence, you don't necessarily want to subtract 2 14 times. That's not even so bad, but what if I asked you for the 58th term in the sequence? You really don't want to subtract 2 58 times, right? But what you understand is that if you're doing the same thing over and over again, subtracting 2 14 times is the same thing as right. It's the same as multiplying. Guys, repeated addition is multiplication. Repeated subtraction is multiplication by a negative number. Okay? If I subtract 2 and then subtract 2 again and then subtract 2 again and then subtract 2 again, well, if I'm looking for the 14th term, then I'm subtracting 2 14 times, right? But, so when we find a pattern that is a repeated addition or repeated subtraction, then we think of that as multiplication. So this equation would be y equals negative 2 times x. Now, that's only part of it though, because is 1 times negative 2 8? No. Is 2 times negative 2 6? No. Is 3 times negative 2 4? No. So this is not the whole rule though, because obviously just multiplying by negative 2 doesn't get me from my x value to my y value. So what else do I need to do? And all you have to do for this is pick one of them. If I look at this x value and this y value, if my x value is 1, my y value should be, so I have 8 should equal negative 2 times 1. Well, that's negative 2, so what else do I need to do? Close. What's negative 2 times 1?
Negative 2.
And if I want 8, what else do I need to do? Add 10. Okay, you can't multiply because if I multiply by something else, then that's going to change what I'm doing repeatedly, right? The multiplying by negative 2 is what tells me that, hey, it's going to decrease by 2 each time. So if I multiply by something else, then it's going to change what this pattern down here. And this pattern has to be a decrease by 2, right? So it has to be negative 2 times something, but we can always add or subtract something additional to it, in which case this would be plus 10. The reason that is, if you think about this chart, if I back this chart up 1, what comes before 1, 8? 0 and 10, right? When my x value is 0, my y value is 10. In other words, before I've subtracted the first two, my original value that I first start out with is 10, and then I'm going to subtract 2, and subtract 2, and subtract 2, and subtract 2, and subtract 2. So this original value is kind of our starting point. We're starting at 10 and then decreasing by 2 each time. So all you have to do is figure out where did we start. So we started at 10. So now my equation is y equals negative 2x plus 10. Then, now we know that works for this one, right? Because that's how we came up with it. We need to make sure that our rule's right. We've got to double check it with another. So if I plug in 2, I have negative 2 times 2, which is negative 4, plus 10, which is what it's supposed to be, right? Or if you tried the next one, negative 2 times 3 is, plus 10 gives me. So it works for any one in the sequence, which means if I need to get to my 14th term, then I need to do negative 2 times 14 plus 10, right? Negative 2 times 14 is negative 28, and negative 28 plus 10 is negative 18. So we can get our 14th term that way. Okay. Oh, sorry, that one we're not even looking for the 14th term. I'm thinking about number 4. So this one we're just writing the rule, which is this, or they just swapped the order. Instead of negative 2x plus 10, they made it 10, positive 10, minus 2x. So our equation is our y value equals 10 minus 2 times whatever the number of term it is. All right, other questions? Raj? Number 6. So for this one, it says, which of the following is a solution to 3x minus 2y equals 6? Now, a solution to an equation means what? If you have a solution to an equation, what does that mean? It what? Okay. Does this have one answer? How many answers does this have? I heard somebody saying it. Infinite. This is a linear equation, right? It has an infinite number of solutions. So it's not the answer. It is an answer. It is one set that will work. So of those 4 options that they give you, you have one x and y value that is an answer. In other words, that will make this statement true. 3 times x minus 2 times y should equal 6. So this is like checking your answer on the solving equations problems we did. Once you find out what x is, you plug it in and see if it works. Well, now instead of plugging in x, though, we're plugging in x and y. So I have the first one, option F. We have x is, what's our x value? 2. Make sure you know which one's x and which one's y. It makes a difference. All right, so my x value is the first one, which is 2. My y value is the second one, which is 3. So I get 3 times 2, which is 6, minus 2 times 3, which is 6. Does 6 minus 6 equal 6? No. So our first answer is not correct. So, since it's not the first one, let's look at the second one. So here I have 0 and 3. So my x term is 0, and my y term is 3. So I get 3 times 0, which is minus 2 times 3, which is 0 minus 6 equal to 6? No, it's negative 6, right? So that means that one's not our solution. So then we'll move on to our next one. So for this one we have 3 and 0. So my x value this time is 3 and my y value is 0. 3 times 3 is 9. 2 times 0 is... So I get 9 minus 0, which is not equal to 6, right? So just by process of elimination, we would assume the last one is correct, but let's double check it just to make sure. So for this one, we have my x value is 4, my y value is 3. 3 times 4 is 12. 2 times 3 is 6, and 12 minus 6 is... So 4, 3 is a solution, not the solution, because remember, the solution is a linear equation that shows every single solution, right? You can't write a pair of numbers or several pairs of numbers and say this is the solution. It is a solution. To show the solution, you'd have to draw the whole line, graph the whole line, because that's the only thing that shows every solution. All right, other questions? Amber.
5.
Number 5. Says, which set of ordered pairs can be used to graph y equals negative x plus 1? Now there's one thing about this problem that has probably messed a bunch of you up on it, which is, let's look at some of our ordered pairs here. So in the first set, A, we have negative 1, negative 2, right? So if I wanted to plug that one in and see if it works, my y value is what? So make sure everyone's following along. We're looking at option A, and in option A, the first value is negative 1, negative 2. You know, we'll check one at a time. You're not going to have to check 12 numbers because some of them are repeated. Right? So, all right, so we have 0, 1, and 1, 0. All right. If I want to plug in that one and see if it's a solution, because remember, to be a set of ordered pairs, they all have to be solutions, right? If any of those 3 is not a solution, then you can't use it to graph it, right? Yes? Everyone with me? Okay, so let's plug in. So I have y. Well, what's my y value here? Be careful, make sure you know it's the second one, right? So it's negative 2 equals, and what's my x value? Okay, now here's where a lot of you probably messed up. If you put negative 1 plus 1, is that correct? Why not? What have I messed up on so far? The x is negative. What is my x value? My x value is negative 1. So if this equation said y equals x plus 1, then I would have negative 2 equals negative 1 plus 1. It doesn't say x plus 1, though. It says negative x. So if x is negative 1, then what is negative x?
1.
Yeah. If x is negative 1, then that means negative x has to be positive 1, okay? Because the negative of a negative is a positive, okay? So be careful if your variable is a negative number and in your equation you're using a negative of the variable, you need to understand that negative x becomes positive x. So So instead of negative x plus 1, here we should have, or negative 1 plus 1, we should have positive 1 plus 1. Now, is this equation true? No, negative 2 does not equal 1 plus 1, does it? So, option A, you can eliminate. You don't have to check 0, 1, and 1, 0, because if any of those three pairs is not on the line, then you can't use it to graph the line, right? Not only that, but if you look at option D starts with negative 1, negative 2, which is the exact same one we just tested. So you can also eliminate D. It's also not the correct answer, right? So now let's move on to one of the other choices. So let's say we look at C. So here I have negative 1, 2. So plugging in to my equation, I have y equals, so what's y here? 2 equals negative x, and x is negative 1, so it'll be 1 plus 1. So does that one work? Yes. So the first value of C is correct. So now we check the next value in C. So the next value of C is, all right, number 2. It says, which of the following values makes the relation a function? So let's start with really quickly, what is a function? Guys, vocabulary is huge in this unit. If I say, what's the rate of change, and you don't understand that rate of change, is talking about how y changes as x changes. Or if I say, what's a function, and you don't know what a function is, it's going to be really hard for you to figure out whether something's a function if you don't know what that means. So, who can tell me what a function is?
It's where is there the x point doesn't have any
Oh, y can cheat, but x can't cheat.
Okay, that's an interesting way to think of it. Yeah. Okay, it's where your x value goes to only one y value. You can't have x go to y and x go to z. Okay, right. X can only go to one y value. Now, there's a couple ways you can do this and check whether something is a function. One way is you can graph it. That's not a convenient way to do it if you're having to draw a graph every time. The easier way is if you make a mapping diagram. You list all the things that are your x values in one oval, all the things that are your y values in the other. So let's look at this one. Here we have our x values are 0, 1, 2, and C, right? For this one? Okay. Our y values are 1, 2, 2, and 4. Now, we want to know what value of C will actually make this a function. Well, let's say that C is 1. Well, if C is 1, then do I need to list C here? Nope, because it's already in that list, right? If C is 1, then 1 goes to 2, and 1 also goes to 4. So is that a function? No. All right. If I let C be 0, which is our second option, option G, well, 0 is already in my x values, right? So now I have the point 0, 1, and I'd also have the point 0, 4. Is that a function? No, because now 0 goes to 1 and 0 goes to 4. And then the third option they give us is -2. Is -2 already in my domain? No, so I'd have to add it. So now I have 0 goes to 1, 1 goes to 2, 2 goes to 2, and actually I listed that one twice by accident. Really it should be,
There's a stream of things.
oh, somebody wiggle the mouse on there. Yes. Every input goes to only one output, which means every x matches with only one y. All right, so we have 0 goes to 1, 1 goes to 2, 2 also goes to 2, and -2 goes to 4. Now, is this a function? Does every input go to only one output?
No.
It does, okay? If you think of this is y. Y is allowed to have more than one. Okay, if x, you have to have one output.